This is for Year 11 methods, and it's covering the coordinates and type of stationary points. The first example is a cubic. F of x equals x cubed minus 12x plus 3. Stationary points are going to occur at gradient equaling 0. Therefore, I need to find the derivative and set it equal to 0. So f dash of x will equal 3x squared minus 12 plus 0. 0 equals 3x squared minus 12. 3 outside of x squared minus 4. I can see the difference of two squares there. 3, x plus 2, x minus 2. Therefore, I have a stationary point at x equals negative 2, and I've got a stationary point at x equals positive 2. So, stationary point at 2 and something, and negative 2 and something. To find that something, I need to sum 2 and negative 2 into my original. So f of 2 will equal 2 cubed minus 12 times 2 plus 3, which is 8 minus 24 plus 3, which equals 11 minus 24 is negative 13. And f of negative 2 is going to equal negative 2 cubed minus 12 times negative 2 plus 3, negative 8 plus 24 plus 3 is going to equal 19. Okay, so I found the coordinates of my two stationary points, but I need to know what type of stationary point are they. And I'm going to use a sign diagram to be able to work that out. I know that my derivative is equal to 3x squared minus 12. And I know when x equals negative 2, when x equals 2, the gradient is equal to 0. What I'd like to find out is, what is the gradient to the left of negative 2? What is the gradient in between negative 2 and 2? And what is the gradient greater than 2? To find out what gradients are either side, so I can determine what type of stationary point exists at those two places. So, if I was to sub negative 3 into the derivative, f of negative 3 is equal to 3 times negative 3 squared minus 12. Negative 3 squared is positive 9 times 3 is 27. 27 minus 12 is positive. So it looks like that as a positive gradient. Is there a number between negative 2 and 2? I can do 0. F dash of 0 will be negative 12. So it's a negative gradient. Therefore, at negative 2, I can see it's going to be a local maximum. I know that at 2 it's equal to 0. So if I choose x equals to 3, f dash of 3 equals 3 times 3 squared minus 12. That's also positive. So I can see that this is going to be a local minimum. So my stationary point 2 and negative 13 is a local minimum, and my stationary point at negative 2 and 19 is a local maximum.